Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 15, 2025, just yesterday. The standout result is a semi-online reinforcement learning method that delivers state-of-the-art performance for 7 billion parameter models, with plus 12.0% on Android World and plus 23.8% on AITW. The paper is titled UI-S1, Advancing GUI Automation via Semi-Online Reinforcement Learning. And as we will see later, the implications for model training are quite significant. In short, the method simulates online rollouts over offline data, uses a patch module to recover from policy drift, adds discounted future returns, and introduces a semi-online performance metric that tracks true online success closely. Figure 1 contrasts 3 training styles and shows why semi-online reinforcement learning matters. Offline learning replays static trajectories, which stabilizes training but limits multi-turnability because the agent's own actions are not carried forward. Online learning interacts with a dynamic environment, which captures long horizon credit but is costly and slow. Semi-online learning reuses static data while preserving the model's outputs, then patches divergences and computes both step-level and episode-level advantages, so the agent learns multi-step behavior efficiently. Figure 2 shows that the semi-online performance metric tracks true online success much better than a traditional offline score. Semi-online performance means testing while preserving the model's own history, so evaluation mirrors live rollouts. The left panel highlights weak alignment between the offline AC high metric and Android World, which misleads selection. The right panel presents a strong, near-linear relationship for semi-online performance, so model ranking stays consistent, and UI-S1 lands near the top. Alright, the table defines how the patch module fixes a wrong action, so training continues instead of stopping. Patch module means a small controller that replaces a mistaken move with the expert move, and, optionally, supplies a short chain of thought. The first row keeps only the expert action, which is the cheapest option. The second row adds reasoning from an auxiliary model, and the third uses the policy itself to generate reasoning so style stays consistent. So, Table 2 shows that semi-online reinforcement learning delivers the strongest multi-turn performance among 7 billion parameter models because it preserves model history and learns long horizon credit. Semi-online performance means testing while carrying forward the model's own actions, which better matches live use. The UI-S1 model leads Android World and AITW Gen, and the combined SFT plus semi-online training beats SFT or offline reinforcement learning alone. Wrapping up, 2 takeaways stand out. Semi-online reinforcement learning lets a 7 billion parameter agent learn long horizon behavior from static data by preserving its own history and patching mistakes, and the semi-online performance metric reliably predicts live results. These ideas reduce costly online interaction while improving multi-step reliability. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.